Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see overview of semiconductors. In this video we will see what is semiconductor, what is the energy band structure of semiconductor, what are the properties of semiconductor and classifications of semiconductors. All those are very basic informations where you would have studied during your school days in your 7th and 8th standard. But I'm going to refresh all those things. That's because only by understanding the basics of semiconductors, you'll be able to understand the construction and working of most of the electronic devices, electronic components, right? To start with, we know that the materials normally classified into conductors, insulators and semiconductors depending upon the conductivity level. Where conductors we call it as a good conductor of electricity, and insulators we call it as bad conductor of electricity, whereas semiconductor has conductivity level between conductor and insulator. And very good examples of conductors are copper, silver and aluminum. All the metals are mostly conductors, whereas wood, glass and diamonds act as an insulator, will not conduct any electricity. And semiconductor, a good example of semiconductor is silicon and germanium, right? And to understand how this materials are classified based upon the conductivity level, you have to understand the energy band structure. What is energy band structure of the material? The energy band structure tells you how the electrons are occupied in a solid or in a material, right? Which makes it to behave a conductor, a semiconductor or insulator. Right, so you will see the energy band structure right now, and for any conduction to take place we need electrons. The flow of electrons is very important, right? And if you take energy band diagram, we have valency band and conduction band, right? And we have a forbidden energy gap. There is something called forbidden energy gap, the gap between conduction band and the valency band. That is called forbidden energy gap, right? And if you take conductor, you can see there will be overlapping between conduction band and valency band, and there is no forbidden energy gap. There is no forbidden energy gap, which means we can say that the forbidden energy gap is 0 electron volt, right? So what will happen is the electrons which is normally present in the valency band can directly move to the conduction band, and because of this movement conduction will take place, right? And that is why metals are very good conductors of electricity. That means the electrons from valency band will easily reach the conduction band without any external energy. It can freely move to the conduction band because the forbidden energy gap is 0. Whereas if you take insulator, the forbidden energy gap, you can see this is the forbidden energy gap. The forbidden energy gap that is present between the conduction band and valency band, it is very high. You can see it is more than 3.0 electron volt. So definitely the electrons which is present in the valency band will not be able to gain sufficient energy to reach the conduction band, right? Because the forbidden energy gap is very high, and that is why insulator will not be able to conduct electricity at any condition. That is, there will not be any flow of electrons. That is, the electrons will not be able to reach the conduction band. And if you take semiconductor, the forbidden energy gap is minimum. That is, it varies from 0.1 to 3.0 electron volt, right? And it varies upon depends upon different materials and different types of semiconductors, right? Whereas here the electrons which is present in the valency band can able to reach the conduction band if it can able to gain energy, external energy, right? If it can able to excite it more, if it can able to get energy, more energy, then it can able to reach the conduction band very easily, right? So which means the energy acquired by the electrons will make the electrons to move from valency band to the conduction band, which results in conductivity, right? And that is because the forbidden energy gap is very minimum here compared to the insulator, and that is why semiconductor can able to conduct electricity at certain condition. So what is only certain conditions? Say for example, as I said, the valency band, the electrons in the valency band will not be able to reach the conduction band without any gain of energy. Only if it gains energy, right, it can excite it and it can able to move to the conduction band. For example, if you take any semiconductor at 0 degree temperature, at zero temperature, the electrons will remain in the valency band and it will not have any energy to reach the conduction band. And so at zero temperature, the semiconductor will not conduct any electricity. That means it will act as an insulator at zero temperature. And if you're going to move the same semiconductor inside a room temperature, right? And inside the room temperature, the electrons in the valency band, some electrons, not all the electrons, some electrons in the valency band can gain some energy due to the room temperature, and those electrons can reach the conduction band at room temperature and it will cause conductivity, right? Whereas if you're going to increase the temperature, if there is increase in temperature, then obviously most of the electrons will gain the energy and it will reach the conduction band. So at 0 degree temperature, it will act as an insulator, whereas at room temperature it will start conducting, and at very high temperature it will act as a conductor, right? This is the normal understanding of the energy band diagram between conductor, semiconductor and insulator, right? And as I said before, you can see that the electrons at room temperature will not be able to reach the conduction band. That is why it will behave as an insulator, whereas at room temperature conductivity starts, and at increase in temperature the number of electrons will reach the conduction band, right? And we can call this scenario as negative temperature coefficient of resistance. Negative temperature coefficient of resistance, that is, semiconductor loses its resistance when temperature increases. When temperature increases, we can also say that when temperature increases, resistance of semiconductor for electricity decreases, right? And that is why we can call it as negative coefficient of resistance, negative temperature coefficients of resistance, right? Now you understand what is semiconductor and what is the energy band structure of semiconductor, right? We will see the properties of semiconductor. So we know that semiconductor can able to conduct electricity under preferable conditions, right? And this unique property makes it an excellent material for conducting electricity in a controlled manner, right? Whereas these are the properties when it comes to resistivity. It is 10 to the power of -5 to 10 to the power of 6 ohm, and conductivity, it is ranges from 10 to the power of 6 to 10 to the power of -5 ohm. And temperature coefficient of resistance is negative. That's because as temperature increases, right, the resistance of the semiconductor for electricity will reduces, right? And the current flow is due to electrons and holes, right? These are the properties of semiconductor. And coming to the important side of semiconductor, which is very basics for most of the electronic components, you have to understand what are the types of semiconductor. So when you take semiconductor can be classified into two different types. One is intrinsic semiconductor and extrinsic semiconductor. When you say intrinsic semiconductor is the purest form of semiconductor. The purest form of semiconductor, for example, it can be a germanium or silicon, right? This atom, this silicon or germanium will have 4 valency electrons. But this pure form of semiconductor will not conduct electricity. That's because it has equal amount of positive and negative charge. So it will be a poor conductor, right? So whereas to improve the conductivity in order to make any components, we normally prefer extrinsic semiconductor. Sir, what is extrinsic semiconductor? Extrinsic semiconductor is by adding impurities to the intrinsic semiconductor, we can obtain extrinsic semiconductor. That is, the process of adding, you have to add some impurities to the purest form of semiconductor so that we can able to obtain extrinsic semiconductor, which can be a good conductor of electricity, right? So you can see here that that is extrinsic semiconductor. That is, by adding impurities to the intrinsic semiconductor, we can able to obtain extrinsic semiconductor. And this process of adding impurities to the intrinsic semiconductor is called as doping, right? And depending upon the materials which is used, depending upon the impurity, right, it can be divided into N-type semiconductor and P-type semiconductor, right? We will come back this little later. And as I said, right now you have to understand what is intrinsic and what is extrinsic semiconductor. Intrinsic semiconductor is purest form of semiconductor, and whereas extrinsic semiconductor is obtained by adding impurities to the intrinsic semiconductor. If you take silicon atom, you can see it has 4 valency electron, and there will be a covalent bond between these electrons, right? Normally, this is the crystal lattice structure of silicon, right? And you can see every silicon atom will have 4 valency electrons, right? And now, as I said, if you're going to add any impurities to this particular purest form of silicon, it becomes extrinsic semiconductor. And depending upon the impurity, say for example, if you're going to add pentavalent impurity, then it will become an N-type semiconductor. And if you're going to add trivalent impurity, then it will become a P-type semiconductor, right? How it is called as, why it is called as N-type and why it is called as P-type, we will see that now, right? So you can see that by depending upon the impurity, the pentavalent impurity is added to an intrinsic semiconductor, it forms an N-type semiconductor. Similarly, if a trivalent impurity is added to a intrinsic semiconductor, it forms a P-type semiconductor, right? And now you can see this diagram is very, very important to understand what is N-type and what is P-type semiconductor, right? Now, normally if you take any silicon atom, you will have 4 valency electron, right? So these are the 4 valency electron for an example, right? And now, if you're going to add a pentavalent impurity, what is pentavalent impurity? From the name itself, you can understand a pentavalent impurity will have 5 electrons, 5 valency electrons, 5 electrons at the valency band, right, at the outermost level. So it has 5 electrons. So when you're going to add this electrons, right, when you're going to add this impurity with silicon, so this 5 electrons will form a pair here, right? So it will have 1, 2, 3 and 4, right? Obviously, there will be 5 valency electron and one electron will be free, correct? Right? So 4 electrons will form a pair, whereas 1 electron will not be able to pair, and this is called one free electron. This will create one free electron, right? So what happens here? Whenever you add a pentavalent impurity to a silicon, definitely it creates one free electron, because 4 electrons will be combined and 1 electron will be left alone, right? And this electron, we know that electrons are negatively charged. We know that electrons are negatively charged. And if you're going to add impurities to like this, pentavalent impurities constantly to all the silicon atom, then the number of free electrons will increase, right? The number of free electrons will increase, and that is why in N-type material, electrons are majority carriers. Electrons are majority carriers, where holes are minority carriers. Holes are minority carriers, right? So if you take any N-type material, electrons will be more and holes will be minority, right? And that's because of this donor impurity, because it is donating 1 electron, 1 free electron. The pentavalent impurity is also called as a donor impurity. That's because it contributes 1 free electron, right? Now the same thing, what is meant by P-type semiconductor? If you take any particular silicon, we know that it has 4 electrons in the valency band, 4 electrons, correct? Right? And now if you're going to add a trivalent impurity, what is trivalent impurity? Trivalent impurity is nothing but it has 3 valency electrons, right? Now if you're going to combine this trivalent impurity with this silicon, what it will do? It will form electron pair, right? It will form an electron pair with 3 of this valency electron, leaving one electron free. That is, there is no pair for this electron, so there will be a hole here. So all this will be having electron pair, right? But this here, there will be a blank space, which is hole, right? And if you're going to constantly add this trivalent impurity, it is going to increase this hole. It will increase this hole that is positively charged. Why it is called as acceptor impurity? That's because there is a hole here. So whenever an electron comes, it can able to attract that particular electron. That is why it is called as acceptor impurity. So it creates hole, and if the hole increases, right, that is called as p-type semiconductor. And that is why in p-type semiconductor, right, majority are holes, whereas minority are electrons. Right. So now you understand what is n-type and p-type semiconductor. Right. So whatever I said here, that is what I explained here. If you're going to add a pentavalent impurities like arsenic, antimony, phosphorus, right, these pentavalent impurities will donate one free electron, and if that free electrons exceeds, right, that is called as n-type semiconductor. And that is why in n-type semiconductor, electrons are majority carriers and holes are minority carriers. Whereas if you take a p-type semiconductor, small trivalent impurity is added, which will form electron hole pairs with all the 3 electrons, leaving 1 electron free without a pair. That is, it will create a hole, right? So the number of holes will increase. So obviously in p-type material, the majority carriers is holes and minority carriers is electrons. Right. So this is the overview of semiconductors, where right now you will be able to understand what is semiconductor, what is the energy band structure of semiconductor, what are the properties of semiconductor, and what is the classification of semiconductor. I believe this video will be very useful for you. Thank you, my dear students.